Welcome to Introductory Physics 1, Physics 211, titled Mechanics and Heat. My name is Dr. Charles Bacon, and I will be your instructor for this course as we look into the properties of mechanics and heat as it applies to the physics of the universe around us. In this course, we will study, in particular, the broad area of mechanics, and by this we mean the motion of objects, whether they be small in terms of atomic size objects or large in terms of galactic size objects. What we will be asking are the questions that relate to why do these objects move, what can we do to describe their motion and predict their future motion, as well as understanding the causes and effects that go along with mechanical motion. By mechanical motion, we are referring to such things as moving in a straight line at constant speed or accelerating, going around in a circle, rotating, whether that's rotating at a constant speed or accelerating, as well as vibrating back and forth, such as a pendulum or spring. These three types of motion will be studied individually. We will develop equations and relationships for these types of motion and be able to analyze them from what we call fundamental principles. And in so doing, we will generate some good problem-solving strategies that we can use. Why study physics? That's a question we get quite often, actually. And one reason for studying physics is that it is a discipline that teaches you problem-solving skills, how to look at problems and how to discern and determine what information you have, what information you're looking for. Are there connections? Can I bring the information in to bear on the problem? And how do I go about finding the answer that I'm looking for? And oftentimes making some reasonable assumptions based on the information. Now, I think those kind of skills would benefit us all in everyday life, as we are all faced with challenges and situations that require us to think critically and to problem solve in our own individual lives. Problem solving is more than just an analysis of cause and effect, and that is, I recall when I worked in industry, we oftentimes referred to some of the things we were doing much of the time as just putting out fires. And by that we meant we seemed to be reacting. Something would happen and we'd have to solve the problem, and it was day after day of firefighting. As opposed to being able to think critically and long-term about what's going on, why is what's happening, and how can we understand what's happening and perhaps predict where this process is going. As a matter of fact, one of the ways of looking at processes in industry is known as the Six Sigma process, in which oftentimes you can be misled into thinking that the problem you're solving is actually the cause, and in fact it's merely a symptom, and you have to dig deeper back into your systems and processes to figure out what's truly the cause behind the situation you're dealing with. So you can imagine those kinds of critical thinking, problem-solving skills are very valuable to employers, and physics is a discipline that teaches you how to approach problems, admittedly from a mathematical standpoint, which is a logical, analytical approach, but how to approach problems in that manner in order to arrive at a solution, or at least a set of conditions that might lead you to a solution. So it's very valuable in order to have these skills. This course is organized around a textbook as well as these presentations that you'll be looking at. We will be doing laboratory experiments to illustrate and validate physical principles. We'll be doing homework in order to get some practice with problems, and you'll have lots of help on that. And of course, as usual, exams to assess your understanding and learning. When will you be able to talk to me? We'll have regularly scheduled sessions, live online sessions that will be conveniently scheduled for all of your schedules. And at that time, that's not the only time you'd be able to, say, chat with your colleagues. However, that would be a time when we would all be there, and you could ask me questions, or if you ask your colleagues questions in a chat discussion or on a bulletin board, that would give me an opportunity to know what questions you have, what problems you are dealing with in trying to solve the homework, for instance, and then at some point I would be able to interject when I see that the class is having a sufficiently difficult time coming to some reasonable conclusion. So we'll have a time scheduled when we can all meet online, so to speak. Can you ask questions of me and your fellow classmates? Well, of course. We have email correspondence. We'll have a bulletin board available, and you can post your questions if the question is something that will help the group as a whole on homework or quick tests and so forth. That's can be posted on a bulletin board. Someone else may answer that question that's dealt with the same question, and so amongst yourselves you may come to a solution. I will monitor that, and when I see necessary to go ahead and interject myself, I will. Anything involving personal information, so forth, you can email me privately, and we can take care of that. You'll find the syllabus inside your textbook. The textbook will look something like this. It will say Physics 1. It may not be this color, but it will say Physics 1 and Active Learning Inquiry. And by active learning inquiry, we mean we expect you to be actively engaged in the process of this learning. The way the textbook is laid out, there are questions to ask, problems to solve, sometimes information to input, things where you may be listening along through the DVD and you need to pause it and answer a question before we go on, or plot out some information on a graph. So to be most effective in this course, we need you engaged in the process so that you can get the practice you need to build the skill base to be able to become an effective problem solver in physics. On the syllabus you will note, which is in your textbook, you will note there are various contact numbers that will allow you to contact us by phone or by email, and of course we will let you know what are the times that will be available in order to have these contacts and talk in the chat room. The required materials include the textbook, which has in it the study material you need, as well as the laboratory descriptions that you will need. Also, there's a physics toolbox that you will need in order to do these laboratories on your own. How are we going to grade the labs? Well, you will have to turn in lab data and measurements and reports in order to get credit for that portion of the class. And those will be based upon using the materials in the physics toolbox. So we'll talk more about that as we go into the lab material. Homework, those homeworks are, and those will be weekly homework assignments. So we'll have homeworks, we'll have labs, we'll have lectures, and as far as grading goes, then we'll also have exams. And every point of homework, all points are equal. So if 10 points in homework, and if we have 14 chapter homeworks, there's 140 points there. If we have 14 labs, those are 10 points, 140 points there. If we have 4 exams, each worth 100, then there's 400 points there. So you get an idea of how many points you are accumulating as you go along, and then you can check to see at what grade are you at that point and monitor your own progress. The organization of the materials follows the broad outlines I stated earlier, that we're going to be looking at mechanical concepts for the bulk of this course. And by that I mean, once again, to reiterate the linear motion, which we call straight line motion, which is motion as forward and backward, up and down, and right and left, as well as rotational motion, objects that are turning and spinning, and as well as vibrational motion, objects that are oscillating, such as springs, pendulum, waves, and so forth. These areas comprise the bulk of mechanical motion, and we'll study the concepts associated with mechanical motion: velocity, acceleration, force, work, energy, and momentum in these three areas of motion. Then there's a companion area of thermal physics, which is connected with mechanical motion in the sense that, as you know, when you slide two objects across each other, you can generate heat through friction. And so there is a connection between these things, and we want to look at the concept of thermal physics, and in fact, how do we extract work from heat? And that's a mechanical connection as well, and that is that the motivation behind, obviously, engines, the steam engine originally and the internal combustion engine, is that we want to maximize the amount of work we get out, the amount of energy we put in. And so thermal physics connects those mechanical principles of the first part of the book with the thermal concepts associated with combustion. So those are the chapters we'll be looking at in this particular course. As I mentioned, the lab exercises are performed by utilizing either materials you have based at home or materials that are provided in the physics toolbox. The physics toolbox will include a number of pieces, pendulum, timer, springs, and so forth, that will allow us to illustrate and allow you to make measurements. Remember that physics is ultimately an experimental science. It is a science that is concerned with measuring and understanding the principles, the fundamental principles that govern our universe. But in order to do that, we need to make measurements of motion for mechanical concepts, measurements of motion, and be able to describe that motion, develop relationships that fit that motion, and then be able to predict the future motion of the objects we're looking at based on these relationships. Without such ability, if things were not predictable in a sense, if there were no cause and effect relationship between what you see happening and why it's happening, then there would be no predictability and there would be simply chaos. But we know that's not the case. The universe is very much, in a macroscopic sense, a mechanical construct that operates according to rules, principles as we call them. And we'd like to know what those principles are. It's kind of like playing a game, a sport, and you want to know the rules of the game, and you don't want the rules to change every few minutes so that you can't know what's going on. So in order to play the game, in order to understand the game, we want to know the rules, and those are the rules we're looking for. Rules such as conservation of energy and conservation of electric charge and conservation of momentum. So we'll talk more about these as we move through the material. As I mentioned, there are exams. The exams are 100 points each. They're cumulative, And that only means this, that because the principles and the information that we develop in this course, such as velocity and acceleration developed in chapters 2 and 3, which then are used in chapters 4 and 5 and subsequent chapters, it's cumulative in that sense, that you can't just simply separate out concepts and then never see them again. So you will be building a foundation of information, a foundation of skill sets that will assist you as you move forward in learning the concepts in the later chapters. So nothing to be concerned about there. A cumulative test is one in which you will be prepared to take because you have been doing the problems and we have been discussing them. So 4 exams, 400 points. Homework is a weekly process. It should almost be a daily process. In other words, if you have 10 or 12 homework problems due for that week, then work on them steadily. Do a couple a day. Read your material beforehand. Take a look at the presentations, and then go to the homeworks and try to use the homework template that we have provided so that you can begin to build a discipline of homework. And by that I mean this. It's a lot easier to do physics if you follow a plan. And so we've tried to provide you with a template that will help you build this discipline. And the template looks like this. The template in the back of your book, by the way, so you might want to make copies of that so you can use that to do your homework. The template starts out with the problem statement. This is some maybe summary, synopsis of the particular problem you're dealing with. So jot it down. It doesn't have to be word for word, kind of your understanding of what this problem is talking about. Now, as you go through that synopsis, that summary, you will see that there are some numbers in the problem, and we call those your knowns. So we want to label those and record those in the knowns box on your homework template. Following that, there'll be a box for relevant equations. And by that I mean equations that pertain to this type of a problem. Doesn't mean you will use all the equations you jot down there. You may jot down 3 or 4 equations, and when you come to your solution space, you find you only need to use 1. But at least you've jotted down ones that you thought applied to that particular problem. You'll know, or you'll begin to know, how to decide what equations apply, because you'll understand from the problem that it's asking for certain information. And so you'll have relationships, equations, that will be used to calculate that question that's being asked. Sometimes you can use one equation and go directly to the answer. Sometimes you may have to use multiple equations. Solve for a bit of information here, plug it into another equation, and so forth. So that's what you're going to be doing in the solution space of your homework template. Building up this discipline of homework solving is very critical. It helps you to create a mindset of how problems flow, and you can then be much more essentially mechanical in the way you do this. So you're not being concerned about whether you're missing information or have you not thought through the process. This is going to help you to think that process through. Finally, of course, we do want to have the answer, so there's a space at the bottom of the template to place your answer. All answers should include units, and if it's a vector, include direction and so forth. So that's the homework template. These homework templates are used to solve substitute your homework assignments. It's always helpful to have certain problem-solving tips when it comes to doing physics, and they may help you think differently about how you approach your physics. One thing to think about is that people differ in the way they study and the way they learn, and there are some broad categories that we can look at with respect to learning. You have in your book a profile that I would like you to fill out. And this profile asks you a number of questions about how you prefer to learn. And then based on that profile, you create a picture of your own preferences. What kind of a person are you in terms of your learning styles? And this is important because it's called, self-awareness. In other words, what kind of a learner are you? Do you learn best in a quiet setting, or do you want the TV on? Does it help you to work with others, or are you someone who prefers to work alone? So we want to know what we are so that we can understand, perhaps if we're having difficulty, it may not be so much the material as it is the way that the material is presented and how that matches or does not match the style of learning that works best for you. Now, that doesn't mean that we're going to alter the material. That just means that you become aware of when you're having difficulty. It may be because you don't like the way that something is being presented, and you simply have to raise that dislike up to a level of consciousness and say, well, I may not like the format, but I can still learn in this format. I just have to recognize that. There's a short section between Chapter 1 and 2, which is titled How to Read and Study Physics. Some tips on perhaps outlining or creating study cards or things like that. The tips may be helpful for you. Also, many chapters have problem-solving sections associated with them that are online. And that is, once the material has been introduced through a chapter lecture, there will be problems online that you can look at. They're solved. There will be certain pathways that are shown that if you have this, if you're looking for this type of variable, then go this direction. If you have a combination of things you're looking for, then go in this direction. So there are several of those kinds of things available online, and we'll let you know where they are and when they'll be useful to you. So that's kind of the introduction to what we're doing this semester in physics. I look forward to working with you. Thank you.